All right, so the title for your notes should be relative dating. If you want to keep going where you left off, this is all the same unit. We've been talking about the history of life on Earth, so you can just keep going in your notebook. Okay, so the title is relative dating. So you'll need this definition in your notes. Relative dating is used to determine the order of events. So not the actual age of something, but the order of events that something happened in. So we talked about the mud puddle. Okay, we talked about the mud puddle the other day, and I asked you what order did these events happen in? Okay, you guys told me that first there was a thunderstorm. Okay, then the kid ran through the mud puddle, he made footprints, and then there was hail, right? So if I asked you, well, how long ago did those footprints happen? Would you be able to tell me? No, you wouldn't be able to tell me the exact date or time that it happened. But you could tell me what order those events happened in, right? You could tell me first there was the thunderstorm. It created the mud puddle. Then the kid ran through because there were footprints. Then there was a hailstorm, okay? So relative dating tells us the order of events. It doesn't actually tell us the age of a rock or a fossil or when something exactly happened, but it tells us the order, okay? So if you think of the word relative, for example, my grandma, right, is my relative. If I just say my grandma, do you know how old she is? No. Okay. Well, you don't know how old a relative is, right? But you know she's probably, if she's my grandma, she's going to be a lot older than me, right? We don't know if she's 65 or 85, but we do know that she's going to be older than me. So relative dating tells us the order of events. Absolute dating, which we'll talk about later, tells us the actual age, okay? All right, so the next thing that we're talking about, fossils, okay? So I'm hiding this definition at the bottom because you only need to write what's on the top, okay? So you might have talked about fossils in another class. A fossil is evidence of an ancient organism that is preserved in rock or sediment. So if we think about the words that are up here, okay, preserved means like saved or kept, okay? So we can think of preserved as being saved or kept. When we talk about rocks or sediment, anyone know what sediment is? Sediment is dirt, basically, okay? Dirt or soil, okay? So sediment we can think of as dirt or soil. Fossils form when dirt or soil or rock forms around an organism. You do not need to write the second bullet point down, but it's more information about how fossils form, okay? So fossils form when an organism dies, okay? So the organism has to die, and all of the soft parts decay, they decompose. If you've ever seen roadkill on the side of a road, right? You see that organism, and some of its fur might be falling off of its body, or if you see it long enough, you might only see skeleton and just traces of hair. Okay, the hard parts end up remaining, shells, bones, okay? And if the conditions are just right, we end up getting a fossil. Now, there's lots of different types of fossils, okay? We can get petrified fossils. Petrified fossils are things like petrified wood, okay? So basically what happens here, we get a chunk of wood, like a little wood chip, and some minerals run through it, basically some water with some dissolved rock and minerals in it, and it ends up forming a rock inside of this wood chip, right, or inside of this piece of wood. And over time that wood decays, but the rock still stays there. So it looks like a wood chip, but it's actually a rock. We also have molds and casts. You might have seen an imprint of like a shell in a rock. That would be a mold or a cast. We have trace fossils, okay? These are fossils that are left behind from organisms, but it's not actually from the organism itself, okay? It's a trace of the organism, meaning it might be its footprint or something the organism left behind. It's not actually the organism. And then we have preserved remains. So preserved remains, sometimes we get a whole animal like an ant or a beetle, and it'll get trapped in like sap or inside of a clear mineral, right? Like tree sap. So you can actually see the whole animal there, okay? Now, when scientists look at fossils, they can help figure out the ages of different rocks. If we look at this picture, okay, one scientist goes to Montana, okay? Notice on the left here, we've got Montana. Another scientist goes to Texas, and they're looking at rock layers. You might have seen like on the side of the road that there's rock layers. You can see the different layers of rock, okay? Well, the scientist in Montana, he finds this like T-Rex head, right, or whatever kind of dinosaur skull, okay? He also finds some shells down below, right? So we see that. The scientist in Texas also found that skull, and he found the seashells as well, okay? What scientists do is they say, well, because these skulls are in the same type of rock, okay, these skulls in the same type of rock are the same age. And so in this case, we see that they're both 45 million years old, right? And these seashells, because they're in the same rock, same type of rock, okay, we know that they're the same age. They don't have to be the exact same level down because we might have like a volcano that erupted on one side, so there might be more dirt there. Okay, but we know they're roughly the same age. Now, here's a problem though. What if a scientist found seashells all over both of these rocks? Okay, so let's imagine that there were these little swirly seashells all over the rocks. Would we be able to tell which rock layers were the same age then? No, right? So we have to pick specific fossils. We can't pick a fossil that's found in lots of different rock layers. We have to find a fossil that's only found in one rock layer, okay? And these have a special name. They are called index fossils. So you need to write this definition down. Don't worry about the big scary chart that's up on the board. So index fossils are fossils that are widely distributed. What this means is that they're found in lots of different places. Okay? And they lived only for a short amount of time because they're only in that one or two layers of rock. Okay, so the fossils, they have to be found, like they might be found all over the world, right? One in Montana, some in Texas, some in Europe, right? So these fossils are found in lots of different places, okay? And they only live for a short amount of time because they're only in one or two rock layers, and that helps scientists figure out which rock layers are the same age, okay? So if we look at this diagram, we see different eras. These are different time periods, and we see some different fossils, okay? So some of you might have heard of like the Jurassic period from Jurassic Park, right? The Jurassic period is right here, okay? So if we look at the Jurassic period, right, we see there's two fossils. So if we find these two fossils in a layer of rock, we know that that rock or those fossils existed during the Jurassic period, however many millions of years ago that was, okay? All right, so here's the last thing we need to write down for a slide. Okay, so before you write this down, let's look at this picture. Okay, we're looking at this picture. So in this picture, we got a little fishy. He's swimming. Okay, the fish is swimming, and then the fishy died. Okay, maybe the ocean dried up, maybe it filled in, right? Fishy died. Now we got this little like lizard reptile guy. Okay, well maybe a volcano erupted and he got buried. Wah wah, he's dead, right? Okay, now we got a monkey. So which one of these 3 layers, which one of these organisms is the oldest? The fish, right? Because he's on the bottom. So the law of superposition is kind of a funny sounding law, but what this says is that the oldest rock layers are on the bottom. So sedimentary or rock layers, sedimentary means rock, okay? So rock layers are deposited or laid down on top of each other. Okay, so rock layers are laid down on top of each other. And so if they're laid one on top of each other, we know that the oldest rocks then are going to be found on the bottom, and the youngest ones are going to be found on the top. So the oldest layers are on the bottom, the youngest ones are on the top. All right, so if we look at these rock layers, okay, we have A, B, and C. Which layers of the rock are going to be the oldest in this picture, A, B, or C? A, right? The ones on the bottom are the oldest, okay? Now, let's look at these, right? We have location 2 and location 3. We need to figure out which rock layer is the oldest and which one is youngest. So can anyone tell me, do we think location 2 or location 3 has the oldest rock? So here's what we need to do. We need to line up these rock layers because we know that if they have the same fossils in the same rock layers, they're going to be the same age. So if we line them up, right, the oldest one is going to be on the bottom, right? So the oldest one would be at location 3. The youngest rock would be the top layer at location 2. So this would be the youngest, okay? Let's try another one. Look at these two. We have location 1, okay, and location 2. Which location is going to have the oldest rock? So if we line these up, right, the one on the bottom is the oldest. So location 1 is going to have the oldest, and location 2 is going to be the youngest, okay? So here's what I need you to do. On your desk, you should have a cutout here, okay? What I need you to do is cut out these 2 columns of rocks, okay, and line them up. You're going to glue them in your notebook, and then you're going to label the oldest layer, the oldest rock, and the youngest rock, just like how we did in the notes, okay?